Yes, come on. Oh, yeah. That one? Oh, you actually do. Okay, I'll take it. I didn't know if you had it. Okay. Good. Well, we will get started. Today we're going to do the lesson first, and then if we have time, we'll talk about the test. So, how do you guys feel? This is our 6th meeting, and next week we don't have class next week because of the Sacred Heart open house. How many of you guys are going to Sacred Heart open house next week? No? Just a couple? Nobody? Really? We scheduled it that way because we know that a lot of people are going to Sacred Heart's open house, which happens at the same time. Then our final meeting is 2 weeks after, so we won't be meeting next week because of the Sacred Heart open house. I think some of you guys are not aware of it. How many of you guys are flying to Sacred Heart? You're not going to the open house?
I've already been. 2. Yeah.
Oh, you've already been there? Okay, that's cool. All right. I'll write that reminder up here just in case, because we purposely did that because I know there's some people who are going to Sacred Heart thing. So our 7th and final meeting is in 2 weeks.
So we only have one more class?
We have one more class, yeah.
So that was our last test?
That's our last test, yeah. So, okay, any questions before we start? Okay, good. Well, let's get back into math here. And I think this will be very useful for us. So I've got the packets in front of you guys. Everyone got their packet. You can put it in your notebook. Okay. So let's look at page 62. And we're dealing with terms in algebra, such as substitution here. And sometimes on this test, you will see some weird kind of math terms. So I want to look at these and talk about how we deal with these types of questions here. Let's start with Blanca. You want to read this first question here, which talks about equations? Yeah, the one in the box.
For all real numbers, x and y, let x and y be defined.
We call that triangle. X triangle y.
Be defined by the equation x triangle y equals x plus 1, y minus 1.
Okay, good. So how would we deal with this kind of symbol problem? Does anybody know how to deal with a symbol here? Hayden?
Oh. I think so. It like gives you the equation at the bottom,
Mm-hmm.
and then the first number on the left is x, and the equation, and then the second number on the right is y,
Mm-hmm.
and then so you just do the equation.
So yes, you want to plug in the numbers, but when they give us this question here, it says 0 triangle 3 triangle 6. So 0 triangle 3 triangle 6. Okay. So we have 0 triangle parentheses 3 triangle 6. What should we do here? Hayden?
So the parentheses are on the 3, 6, so you do that first.
Yeah, we follow PEMDAS rules, so we're going to do that first. So if you did that, you're going to treat your 3 triangle 6 like, oops, 6, as if it was x triangle y, okay? And really what they're trying to do is see how well we follow steps, because they're giving us steps here. So when we plug them in, let's do this. 3 plus 1, 6 minus 1. Okay, so now we're dealing with numbers. It's something we're familiar with. So we deal with the parentheses first. What do we get here? Nobody sees this? It should be 20 because this is 4 times 5. Okay, are we done? Okay, what do we do next? Is Hayden the only one awake? Okay, William?
So we would try to isolate the triangle?
Not really. The triangle is just telling you do this formula. That's what it's telling us. Just do this formula. That's all it's doing. Hayden?
So there's still the 0.
So you have 0, triangle 20 now. That's what you have. So you have 0, triangle 20. We're going to do the same thing over again. So you guys should be, if this was not familiar, and you guys are scratching your head like Omar's literally scratching his head there, you should be writing this down. Because if it wasn't something you thought of, so far the only person who knows this and has it down is Hayden. Okay? Everybody else is like, what are you talking about? There's no such thing as triangle in math. There is no such thing as triangle in math because these are symbol equations where they're trying to see how well you follow steps. And so you have to follow this formula whenever you see a triangle. This is the triangle right here. So you have 0, triangle, 3, triangle, 6. You did the triangle here. So that's how we got 20. Now we're going to do the triangle again, 0, triangle, 20. I should see pens and pencils moving, okay? That's what we should see. So this is 0 plus 1, 20 minus 1, okay? So we're doing it again. This should be pretty easy. 0 plus 1 is obviously 1 times 19. Final answer is 19, right? Does everybody see how we got that final answer there? Can you guys all see that? Let's step out of the way here. You guys all see how we got that? Is this kind of weird? Okay. These kind of problems are pretty common whether you take HSPT or whether you take the SSAT, because they like to kind of do some weird things here. Things that are more familiar to us are at the bottom of this page, where you have things such as A times the quantity, B plus C. This is just telling us that we distribute the A times B plus A times C. That's distribution there, okay? And on the right, you can see that they're dealing with a common denominator, A divided by C plus B divided by C. That's a common denominator. We can add those. The only difference is we're just dealing with, instead of just fractions, we're dealing with variables now. So what was less familiar is actually just something that we should be used to. Okay, everyone do these 4 real quick. We'll go over them right below those, okay? Okay, everybody work on those problems. All right, do we have answers here for these questions? Do we have answers for these 4? It should be pretty straightforward here. Are we ready? Give it another few seconds here. Follow the rules of PEMDAS, even though you're using variables instead of numbers, okay? Okay, let's go over these real quick. For the first one here, it's for 2 times the quantity, 3 plus x, we should have gotten 6 plus 2x. on that one. For the one right below that, it should be 6R minus RS. For the one on the top right, that should be common denominator here, 5 over X. Okay, and then the one below, you needed to find a common denominator. And the easiest one is 6 for your common denominator. So your answer is 5X over 6. Everyone got that? Okay, no need for explanations here. 5X over 6. Sure, let's talk about that one. Let me erase what we have here. Okay, everyone can see that, right? X over 2 plus X over 3. Since we don't have a common denominator, we got to think of the lowest common multiple for 2 and for 3, which is probably 6. The easiest way to do that is multiply each of the terms by 1. Does everybody know why I'm saying this is multiplied by 1? Because 2 over 2 is 1, 3 over 3 is 1. So this becomes 3x over 6, 2x over 6, 5x over 6. Does everyone see that? So our answer there is 5x over 6. Any questions? Okay, good. Let's keep moving here. Let's do these. Let's see if you guys are familiar with isolating variables. Let's talk about number 1 together for a second here. Let's have Dylan over here read number 1 for us.
If x equals y plus 2, what is the value of 3x minus 4 in terms of that?
How would we start this question here? How would we start this question? So in the math world, when they say in terms of, okay, what they're saying here is express this equation, instead of using x, use y. Okay, William, you want to take a stab at it?
Why did they use Y?
Because they want to, this is how I would put it. Since, think of it this way, if you had to translate everything from English to French, this is like saying, this is in French, translate it now into English. That's what they're saying, okay? So what they're doing here is this, and how many of you guys are like, I haven't dealt with this yet? So it's a few hands here. So what I'm trying to tell you is this is expressed in x in terms of y, right? This one is just in terms of x. There's no y here, right here, 3x minus 4. Do you guys see that? There's no y. Everyone agrees with me, right? So the only way you could do that is instead of writing x, we're going to write y plus 2. So I'm going to substitute this into here, okay? So this is going to look interesting. It'll be like this. 3 times the quantity, y plus 2 minus 4. Okay? Does everyone see what I just did right there? So no longer am I talking about x. Instead, I'm talking about y plus 2, because that's what x is equal to. So distribute. So this is 3y plus 6 minus 4. And because of that, I got to simplify, of course, subtract the 4 from the 6. So this is 3y plus 2. And our best answer is E. Does everyone see that? So don't just circle the answer and go, okay, cool, I got the answer. Write this down. Okay, because I saw a bunch of faces here that were like, huh? Okay, so people should be writing down the steps, because if you don't write the steps, you won't remember how you got there. Okay? It's not just about writing the final answer, it's about writing the steps. Because when you do this next time, I'm not going to be there to explain it. So let's try one more. I feel like this is kind of new for some of you guys. Let's try number 2 here. Let's hear new voices. Let's hear from Marcus. You want to read number 2 for us?
If n equals 3b plus 7, what is the value of n when b equals 4?
Okay, and then they're asking when b equals 4. So what do we use with that information? Dylan? There you go. That's right. Good. So you guys are seeing how the substitution works there, right? So answer is 19 right there. Let's try another symbol problem here. They give us a formula. There's a diamond formula here. Let's go with Olivia. You want to read that one for us?
For all real numbers P and Q, let P and
P diamond Q. Yeah.
equals 2P plus P times Q. Wait, what is real numbers?
Okay, who knows what real numbers are? William?
I can't give an exact definition, but it's like I think there's like terminating decimals, I think it's all imaginary numbers.
That's right. All non-imaginary. And Hayden, did you want to add something to it?
All rational.
Rational and irrational. So some of you guys are like, that still doesn't make sense to me. Okay, this is what it means. It means whole numbers, fractions, positive, negative, 0. Okay, doesn't matter whether it's a repeating decimal or a terminating decimal, any decimal is okay. Imaginary numbers, which you guys haven't dealt with, are things such as the square root of -1, which is, this is just a side note, which I don't think you guys are going to deal with it right now. But if you put that into a calculator, it's going to give you error. And imaginary numbers, this actually equals, -1 equals I squared, which you guys haven't dealt with. I know that. So the answer to this is I. And you guys are like, what? But this is stuff from Algebra 2.
Is pi considered an imaginary?
No, it's any number that regardless if it's terminating or non-terminating, it's considered real.
Alright.
This is not real because it's an imaginary number. And some of you guys are like, okay, pass. But let me get back into this for a second. This P diamond Q is just saying you could put any number, whether it's whole number, fraction, decimal, you can put anything in there. That's what they're saying. As long as you don't put the square root of radical 1. That's the only thing that you shouldn't put in there. And I don't think you guys are going to put the square root of radical 1 in there. So anyways, of -1, that is. So this P diamond Q formula tells you 2 times P plus P times Q. So they're asking about 4 diamond 2. If they're asking about 4 diamond 2, okay, all we need to do is identify 4 for all the P's and 2 for all the Q's. So let's just put them right in there. Okay, so what's our final answer here? Aiden? It should be 16. Does everybody see how we got that? Answer 16 there. Because we put 4 for all the places where P is located. We put 2 for all the places that Q is located. Then we just calculated, and we got the answer right there. So it's 16. Okay. Let's move forward. Any questions on that, or are you guys okay? I want you guys to write down the steps. So that way you will remember those things, okay? Because if you don't write the steps, you won't remember it, okay? Let's move on from there to the next page, which deals with translating from English to math. And when we translate from English to math, okay, a lot of times they don't give us equations, so we've got to do that on the spot. Let's have Thomas read this question at the top.
Paul has $U and Margaret has twice as many If Paul gives $5 to Robert, how many dollars in terms of D will Robert have?
Okay, so when you see names and variables that they assign to them, we should kind of define each one of them, okay? So the easiest thing to do here is this. I would say Paul is equal to D. The second person here is Robert, okay? But instead of writing 2 times Paul, how would we write that? Yeah, Olivia, 2D, yeah. So this is Robert. Because they're dealing with the variable D. They've kind of given us that to deal with it. So now it says if Paul gives $5 to Robert, okay, how do we re-express both Paul and Robert? William, what would you do?
Paul is giving it to Robert, so Paul's equation is D minus 5.
Okay.
And then Robert is D 2D plus 5.
Right. So Robert becomes 2D plus 5. So this is all about translating. And for some of us, you might not like the way it's kind of like with variables. So for some of us, it might be easier to turn D into a number. So you could have said, if Paul was originally 10, you could have said 10, and then you could have said Robert was 20, and then it would make more sense. You're like, oh yeah, it's 25, I can see that. If that helps you, go ahead, feel free to plug in numbers. It doesn't hurt to do that, okay? Any questions on how we did this so far? We can kind of go further with that, or I can show you numbers on that. Okay. Before we continue, at the bottom of this page, you can see a box that says translation table. This is super helpful to us because a lot of times when we're not familiar with the words for translating from words into equations, if we memorize this, we'll be able to deal with those things. Some of them are obvious, like equals and is. Those all mean equal sign. Times, of, multiplied, product of, twice, double, half, triple, they all mean multiplication. I'm going to state this. The word of is one of the trickiest words. Because if you look at the next line, which talks about division, you can see it says out of, ratio of. So of pertains both to multiplication and to division, depending on the words that surround it. Okay? If it's just of by itself, it's multiplication. But if it's out of, it's division, or ratio of. There are other contexts. Quotient of is what? Division. Product of, it's in there right there. How about percent of? That one usually throws people off.
Multiplication.
So I'll write a sentence here. Okay, I wrote a sentence. 5% of dentists like candy. How would we change this into an equation? William, what would you do?
0.05 times 0.05D. Represent dentist.
Okay. 0.05 D.
0.05.
Oh, sorry. Yeah. 0.05. 0.05 D, and then what?
Equals like candy.
So even though like wasn't on our list for equals, in this equation, we know that there's another term, which is candy. So it's going to be equal to C. You guys see that? Because that means 5% of dentists, if there are 100 dentists, 5 of them actually like candy. The truth of the matter is 99% of dentists like candy. In fact, they love candy. You know why?
Couldn't have to get money.
Because it keeps them in business. When you eat candy, they stay in business. And only say 1% are like, well, I don't really like it. I'm more into savory foods. But 99% are like, go ahead, have all the candy you want, have more. You know. So, anyways, okay, back to this. The point of this is that we need to get used to seeing some words in 2 different contexts, specifically multiplication and division, the word of, okay? Some of these are also straightforward with addition, subtraction. I'm going to also talk about one other phrase here, less than, okay? And I don't know if I said this previously, but I'm going to reiterate it because I think a lot of students don't catch this the first time. Is there a difference between these two sentences here? Is that a hand, Omar? Okay.
Well, one is saying subtract,
Uh-huh.
and the other one is saying, I just don't know.
Okay. Dylan, over here.
One of them is saying 2 minus 10, and the other one is 10 minus 2.
Which one's which?
The first one is 2 minus
10 less than 2. Is saying, say it again?
10. 2 minus 10.
Right. So this is 2 minus 10. And then this one here?
10 minus 2.
10 minus 2. Right. Does everyone see the difference? It's just one word. Less than and less. Okay? And they mean two different things there. So this is something good to write down. What I'm trying to train you guys to get used to these words because sometimes they're a little bit tricky. Okay? All right, good. Those are all pretty useful there. When they say what or how much, they really mean X, whatever variable you want to use, and D, whatever you like. When you choose variables, pick letters that are easy to remember. If it says Bob's age and Carol's age, what are some easy variables, Tula? Sure. For Carol, A?
No.
Sure, you can if you want. She has an A in there. So that works. B and C might have been more obvious. Okay, the thing, number of cats and dogs. Tyler, what would you use as variables there?
C and D.
C and D. What about Omar? If you have price of cucumbers, price of carrots, what would you use?
Cumbers and carrots.
As a variable, a whole word?
No.
Okay. All right. William?
U and A.
Yeah, U, and I use the second letter because the first ones are the same letter. You can't use C and C, right? So that's why you wouldn't use those. Okay. Let's move on from there. This is just kind of quick stuff. Let's see how you guys feel about some of these questions and translating them. Let's go with Blanca. You want to read number 4 for us?
If 4 is subtracted from a number, the result is 9. If the same number is multiplied by 3, the result is...
Okay, so before we even read the second sentence, guys, the first sentence is what we got to deal with here. What can we do first? Tula?
Oh, you said right. 4 minus X.
Is it 4 minus X?
No, X.
It's X minus 4, subtracted from. So let's write this, X minus 4, okay. What is the rest of it saying to us? William?
Equals 9.
Equals 9. Okay, good. And then, okay, yes.
Add 4 for both sides.
Right, so Dylan said let's add 4 on both sides. You get 13 there. What do you do with this now? Okay, yeah, good. Thanks for finishing that. So it says, with that result, okay, you multiply by 3. What did you get here, Dylan? Since you
39.
39. That's right. So this is what I want you guys to take away from this. Reading the whole thing, you're going to do that eventually, but try to translate the first sentence before you get to the second one, okay? Because that helps you a lot, all right? Let's try the next one here. Let's have Omar, you want to read number 5 for us?
Jennifer is now 10 years old. Danny is 2 years younger than Jennifer. In terms of, and how old will Danny be in 5 years?
Okay. So what would you do here? Okay, William, what would you do?
First I would translate the sentence.
Okay,
Jennifer is obviously N years old, so you could put J equals N. And Annie is 2 years younger than Jennifer, so that's N minus 2.
okay, good.
And then, in the terms of N, how old will Annie be in 5 years? You
Right,
can add 5 to both equations because, there's
5
they're
years.
both growing in 5 years.
Right. It's not like one person stays the same age and the other person keeps growing, right? Okay, right. And then what happens?
Then, Annie is, 10 plus 3, and Jennifer is N plus 5.
Right. This should be, I should say A plus 5 is equal to that. J plus 5 is equal to N plus 5. But this is really what we're interested in, which is how old will Annie be in 5 years? A plus 5 equals N plus 3. Does everybody see how we got that? You could pick numbers here. If you didn't like it and you're like, I don't like dealing with N, let's deal with real numbers. Let's just make Jennifer 10, Annie is 8, 8 plus 5 is 13, right? So if you think about it, 10 plus 3 equals 13 also, if you wanted to do it that way. Does everybody see it? Which one's easier? Just dealing with the variables or putting numbers in there? Variables was easier? Okay. All right, let's continue. Let's see if you guys can do 6 and 7. We'll go over these together. Go ahead and do that for a second. 6 and 7. Try 6 and 7. These take a little bit of effort to translate. Okay, you guys ready to talk about this, or how are you guys feeling? You guys ready? How many people are ready? Doesn't look like it. Okay, let's give it another minute here. And I just wrote this. If you don't remember it, take a picture of this because this is important. Don't come here next week because we kind of opened that up for people who are going to the Sacred Heart open house, which happens at the same time, 10 a.m. next Saturday. Because several of you guys are applying to SH. So, and usually, the reason why we made this exception was because if you read the application on SH, it says, did you come to our open house? And if you say, no. Did you shadow? No. The next question should be, are you seriously interested in coming here? That's really what they're asking when they say that. Like, did you even really care to come here? Do you really know what SH is? Okay, that's what they're saying. All right, let's talk about these. Some of you guys might feel that this was a little bit hard of a question for 6 and 7. How many of you guys got both of these? Not yet? Okay, let's talk about 6 first. Who wants to volunteer as to how you translated this into an equation? Anyone here? Hayden? What? Okay, or what did you do? Let me hear if you got the right answer first. What did you get? Okay, that's right. Let's continue. What did you do?
So I chose to find online where there are 2 factors, which is 12. So it was 8 12 and 3 12.
So for 2/3 and 1/4. So yeah, he said 8 12s and 3 12s. That's fine.
Yeah, I have one, and that's the left. So those are the people who had shared.
Right.
And the 5 people didn't have drinks, which means that 112 is 112 is 5 people. So I have 5 12.
You could do that. So I'm going to fill in some of the blanks. If you guys were not following Hayden, what he said here is this: 2/3 of the total of the people, 1/4 of them plus 5 equals the total. That's an equation there. You guys, so if I read this again, I just want to do this because he got the right answer and he's following the exact same thing here. 2/3 of the guests, I mean the total guests, drank only soda. 1/4 of the guests, which is the total guests, and then 5 remaining people. If you add it up, that's the total. That's why I said T. You could use G or T. It doesn't matter what you use. He's right to find the common denominator here. You could do that. The only thing about that, so just for these two, that would be 11 12ths T plus 5. And then if you multiply 12 to get rid of everything, so you multiply all of these by 12, you're going to get 11T plus 60 equals 12T. Subtract 11T on both sides, 60 equals T. That means the total people is 60. So he did it right. I just kind of wanted to fill it in just in case you guys didn't see an equation, but when you see an equation, it makes more sense. You guys agree with me on this? Okay. So any questions on this one? Did you guys get different answers on this, or was this, okay, good. All right. Let's talk about the next one, which talks about tolls and driving here. All right, so did anybody get number 7 here? Olivia, all right, you want to tell us what you did here?
So I started with T equals, well, T is for toll.
Toll, okay.
150 plus 0.25 M per mile.
Oh, okay, $1.50. That's what she has, right? Is that how you did it?
Yeah.
25 cents times M, okay.
And then, so she paid a $25 toll, so I substituted toll for 25.
Right.
And then I subtracted 150 on both sides.
Okay,
So then
continue.
I got 23.50. And then I divided both of them by 0.25.
And
And it's got 94.
94 is correct. That's the number of miles that this person drove. So translating can be kind of tricky. You've got to look at these equations very closely. Each number plays a role. The reason why I'm really emphasizing this kind of math is because I know that a lot of you guys do things in mental math. You just do it in your head. But as you start to deal with variables, sometimes more than one variable, it gets harder and harder. So you can't just do it in your head. You've got to write stuff down. Okay, so this is very different than stuff you did maybe in 5th and 6th grade, 7th grade, where you could just do it all in your head. You've got to write stuff down. Okay, let's move forward here. Let's just keep going here. Let's talk about solving for a variable. And this is kind of, I actually think this is easier than what we just did. This is just, when they say solve for a variable, what they're saying is isolate that variable. So that's isolate the variable means when it has a bunch of numbers added to it, subtracted from it, multiplied or divided, you want to move all those numbers to the other side of the equal sign. That's what you're doing here. And when you do that, usually you've got to multiply on both sides, add on both sides, subtract on both sides, do something like that. Let's start with this one at the top here. Marcus, you want to read that for us?
If 1/3 x equals 8, then 1/4 x equals.
Okay. So what would you start with here?
I would start with doing 1/3 x equals 8, and I would multiply them or do the 1/3, so 3/1 times 1/3 on both sides.
Right. So he said just multiply 3 on both sides. I want to emphasize this because I've tutored a lot of students. When I hear them say things, this isn't what Marcus did, but it just reminded me of what I hear. A lot of people say, yeah, move that 3 over. You're not moving it. It's not physically, it is not moving anywhere. You are multiplying. That's exactly what Marcus said. Multiply 3. If you do that on the left, you're doing it on the right. That's what keeps it equal. What did you get on this, Marcus?
X.
Now what do we do with the 24 here?
You do 1/4 times 24.
That's right. So 1/4 times 24. And what did you get on that one?
That's 6.
You got 6. All right. That's the right answer there. Okay. I think that's pretty good technique there. He did the right thing. He isolated the value of x, then he substituted it into the second equation, which is 1/4 times x. Okay. Let's see if you guys can do these. These should be quick fire here. Let's everybody work on these real quick. Let's see how you guys do. Okay, do that for a second. At the bottom of the page. Remember the order of operations. And when you're isolating a variable, you are doing the opposite of what you see. If you see multiplication, you're going to divide. If you see addition, you're going to subtract. If you see subtraction, you're going to add because you're isolating the variable. Okay. You guys ready to talk about it? Still working on it? Listen, Tyler, you want to help us on that?
Yeah.
On both sides. If you see addition, so you subtract. You subtracted 7 on both sides. It becomes 6/8 equals 30 top. It becomes A is equal to 1. Dylan, what did you get on the next Dylan over here? Next to okay. Does everybody see what I was saying? You do the opposite of what you see. There's subtraction going on here, and then you add on both. And that one thing here. Good job on this, Dylan. I was going to say the one thing I want you to think of. You guys all know what PEMDAS means, right? PEMDAS. Everyone's like, yeah, I know PEMDAS. I don't know how long ago. Okay, so when you isolate a variable, which is what we're doing here, you're actually doing SAD math. How many of you guys have ever heard SAD math? Blanca's heard SAD math. Hayden has heard this. Okay. Why do we do SAD math, Hayden? That's right. You do the opposite of what you see. When Dylan explained this, let's add, right? So he's going here. There's no parentheses, no exponents, multiplication because we saw. So when you're isolating, okay, it's when isolate that. Yeah, William, you want to do the next one? Tell us what happened here.
I got -2.
-2 is right, and this one's more straightforward. Tell us what happened here.
I subtracted 3A and 4A because they were like terms.
Okay.
So you have to simplify them.
Right.
So then it's A,
Right.
negative A. If the negative A equals 2, then
Technically, -1 times A, and this is 2. Let's do this. Let's move on to the next page. Problems here. What do you guys do with it? In a second. I'll be right back.
Oh, because we did, we thought that our right.
Okay. So we got some betting going on here on the side. So that's good. Okay. I have good hearing. So, anyways, let's get into this work and you got 30.
No, it's
Oh, darn.
it's the second.
Okay, well, let's have Tyler. There's a bet on number 9. What the next one?
Get rid of the -4 by adding 4.
Okay. And then what happened when you added 4? One J equals 3, and then what? Yes, multiplied 8 equals that. Yeah, that's fine. And what'd you get for J?
I got J equals 1.
That's right. The answer is 4, 9. Okay, just for that only for us. And you can be here on camera, so it'll let you Tyler, they're from Fortnite. I would rather challenge him and maybe do the Fortnite dance. That's a negative 4. I was listening to and then subtracted the 15 in Berkeley when I was teaching a class over there. Everyone did their fortnight dances, and it was hilarious. 95 because they told us. That's right. They told us Celsius equals 95, so we did that.
And okay, multiplied f by 5 9 is 32.
Do that. Yet there's a faster way to.
Okay.
What's a faster way to do
both sides by 9?
Yes.
I did that after.
Because you end up like distributing this.
Yeah.
So
we get.
Don't distribute. You know why? Isn't it easier to get rid of this 5 by dividing both sides? Why distribute and let's add 32 opposite of what you say. Okay, let me rules of slating a variable. When you look at a everything right? Other terms here. So trying to get rid of it. How you do that, you see division, multiply, right, first. Then we're going to do it 10, 15. We got here. Let's talk about inequality. So, okay, let's this first here. I would rewrite the first sentence, first part of the first. Let's translate from English to math. And they give us some lines. If you look right below that box, blank is less than W, and blank, or W is. So how would we do that? What would we say here? Well, W is greater than 4. Less than 11. That's what they're saying. Okay. And then so between you're using overlapping terms. But go ahead, Dylan. We're no longer acknowledging number 5, 6, 7, 8, 11 these each other. They're 9, 11, and 11 is 10. That's what they're saying. Does everybody basically that's each other? They don't. Any number. Okay. So that's how they do that. And I think what's tricky here is just being familiar with the terms less than, greater than, and making sure that you're putting them in the correct order. Also note that they also have the less than to send that looks like. Okay, let's do this next one. Blanca, how would you translate after that paragraph? It says X is more than 4. How would you translate?
I would put 4 and
Uh, what do you mean by and then? Okay, so what goes between them? So, so all they're saying here is that the read comes this, right? Everybody knows that, right? When you multiply it or divide. And it says that right there. And when they sign, they need this thing. Changes. Okay. Do that for like a few minutes here. And I think that the guys who are leaving will be leaving pretty soon. So, otherwise, I'm just gonna quit. If you guys are leaving, so the second is fourth. That's what we should have gotten on that one. On the third one is A is less than 20. The fourth one is X is greater less than or equal to 8. And the last one here is N is less than or equal to